So before we go ahead and try to answer this question, it's worth reviewing what even and odd functions are defined as mathematically. Even functions are defined as being symmetric about the y-axis, that's the vertical axis, and as such, f of x will be equal to f of negative x. For odd functions, they're defined as being symmetric about the origin, which is the center point in the middle of a typical graph. It's that center point right there. Such that negative f of x will be equal to f of negative x. And that'll start making more sense as we go about some of these examples here. Starting with question 1, f of x is equal to x squared, and it asks whether it is even or odd. So here we have the graph of f of x equals x squared, and just immediately you can pretty well see that if you draw a vertical line on the y-axis, and if you were to fold this in half, you would get a symmetric graph. You would have two halves that equaled up to each other when you folded it in half. And to prove this, we can look at our equation here, which states that f of x has to be equal to f of negative x. So for our case for this question, we can ask, is f of 1 equal to f of negative 1? F of 1 in this case is equal to 1 squared, which is equal to 1. And f of negative 1 is equal to negative 1 squared, which is equal to 1. And you can see at 1, we're equal to 1. And at negative 1, we're equal to 1. So this would be an even function. Looking at g of x is equal to x cubed. Here's the graph for x cubed. And again, immediately, if you wanted to look, we can see here at the origin, if we were to rotate this all the way around, and essentially just flip it across the origin, we would have a symmetric graph. And looking at the equation for odd functions, it states that negative g of x has to be equal to g of negative x. And again, we'll just go ahead and use 1 as our number for x here. Negative g of 1 will be equal to negative 1 cubed, which is equal to negative 1. And g of negative 1 is equal to parentheses negative 1 cubed, which is also equal to negative 1. So this is an odd function. F of x is equal to the square root of x. So looking at the graph, it's immediately evident that this is neither symmetric about the y-axis or the origin, but to prove it using the equations that we have, f of x must be equal to f of negative x. Omitting this, if we look at x equals 4, f of 4 will be equal to the square root of 4, which is equal to 2. But f of negative 4 is equal to the square root of negative 4, which gives us 2i, an imaginary number. And since we're just simply plotting on an xy graph, we're not going to see anything on the imaginary plane. So these are clearly incongruent with each other. They're not the same. To look at the odd example, negative f of 4 is equal to the negative square root of 4, which is equal to negative 2. But f of negative 4 is equal to, again, 2i. So this is neither even nor odd. And with the cubed root of x, it's very much the same situation. Immediately looking at the graph, we can see that it is neither symmetric about the origin or the y-axis here. And looking at our equations, we can very readily see that this will be the same case as was with the square root of x.